Hello, everyone. I'm Mr. Franklin. This is your weekly update for the week of September 21st. So this is going to be an overview video of the week where I'm going to explain all the assignments, what I'm looking for, and so that you know what to work on, even if I'm not available to help you out a little bit. All right, so without further ado, let's jump into it. So first thing you do, you sign into class, and you should go to modules, and you should actually go to here. You should minimize all the weeks that you're not working on, and we are going to be in Force in Motion Part 3, but I've also added another module for the quarter project, which we will talk about here in just a minute. So once you're here, you should go into the overview and agenda page. Right here is where I'm going to put the link to this video, so hopefully you have found it. Okay, so now that we're here, the first thing you should think of is you can almost use this like a checklist. Yes, I did that one. Yes, I did that one. It should all be in order, so you don't necessarily have to do that, but I also know it can be confusing with everything posted at once. And I recommend that you do as much in order as you can, but if you're working through this and you're done and you have extra time and you want to go ahead and jump down to the video notes and work through those, then feel free to do so. So let's look at the whole week very briefly, and then we'll go assignment by assignment. First assignment is the what do you think on acceleration. It's going to be pretty cool. You're going to get to watch a video and look at the Orion spacecraft and some other things. Then you're going to watch some video notes on Newton's second law, which is kind of going to put some of our graphing together along with force equals mass times acceleration. There's going to be a textbook time where you're going to read some more about acceleration, uniform acceleration, and constant acceleration. So here's the quarter project for this week. If you turn it in early, I will give you extra feedback. I will also be lenient on grading it. We'll jump in more in detail when we get to that assignment here in a minute. On Tuesday, we're going to meet live. We will probably talk about the lab and then also review any questions you've had so far from the homework. Then on Wednesday, you have video notes and some practice doing acceleration graphs, which are different than distant, straight up constant speed graphs. Then we'll have another live class where we will review and work any problems that we need to do with graphing, maybe even review some 7-step problems, that kind of a thing. And yeah, and then Friday you have your quiz. So one of the big things is this may feel a little bit lighter than some of the other things that we're doing, but part of that is because of the quarter project you need to be working on. So as well as I'm trying to give you a little bit of a chance to catch up. So make sure that you are getting this done, but also working on all those things that are missing. So let's go assignment by assignment very briefly and take a look at what I'm expecting. Okay, what do you think acceleration? Should be pretty self-explanatory. You're going to watch a video on the Orion spacecraft, which is NASA's version of the spacecraft that's going to the moon. And you're going to get to tell me about that. I've given you the definitions of acceleration. And it's basically if something's changed its velocity, it has accelerated. And velocity is speed and velocity is direction. So if the speed changes, it accelerated. If it changes direction, it accelerated. So you could go 60 miles an hour, but turn around in circles and still be going 60 miles an hour, but because you changed direction, you accelerated. So then you're going to watch, keeping that in mind, you're going to watch the Orion actual test flight, the launch, and you're going to tell me a couple of instances where you saw a change in motion, direction or speed. Or pick any of these examples, pick any of these examples, and you're going to tell me what force caused that acceleration the best you can. So this is a what do you think? We're not looking for the exact 100% correct answer, but we are looking for you to think and your thinking to be reasonable. Okay, pretty simple. Next is video notes on Newton's second law. Just remember that when Mr. Bemke asks you to pause the video and take notes that you do that. And there are a lot of drawings and different things. You really need to get those down, okay? Also, don't forget to write your summary at the end. Okay, next, textbook time is actually pretty straightforward. So this one says the Plex is optional. It may be confusing, so let's click on it and take a look. So here's the text, you read the text, and then here in the middle is an optional thing where you can, yeah, it's this one, where you can click on it and play around with the animation, but these animations aren't as good as the Explore Learning animations, but it wants you to drag the red curves to the correct graph. So if we have velocity, and we haven't really talked about this yet, so you can try it and see, but it could be a little difficult, okay? So this is actually, I think, the correct answer, okay? And then there's lots of questions. So you can click through this, and if you understand, then great, that's awesome. But this is optional. It will help if you understand, but it can, if you don't understand what it's saying, don't beat yourself up about it, because we're not going to go through this a whole lot. Okay, so that's what I mean by the Plex is optional. This little animation thing that says launch on this first one is optional. So now, the second one, it says do the simulation in the middle of the page. So the second thing you read, I do want you to do the animation, and I want you to read carefully the instructions in the Google Doc, because basically this is letting you watch somebody fall and watch their acceleration. And so you're going to be able to think about how he's changing his velocity, what that looks like, okay? And then you can see how he's falling farther and farther and farther, okay? And I really want you to go to the sim, because here with the sim, you can turn off air resistance and it's gonna look different, okay? If you turn on the air resistance, you're gonna notice that it's not quite as spread out, okay? So this is more just for you to play with and just to kind of look at the graphs and see what kind of shape they're taking, because that's one of the things we've been talking about. Okay, let's go back to our document. So very simple questions, and then you have acceleration due to gravity, okay? And number 8 is kind of a thinking question. You're gonna have to think about it. It actually may not be quite explained in the text, but there is an example similar but different to what I'm saying here. So read carefully and answer those best you can. Okay, so that was Monday. But if you go back to modules, you'll notice that on Monday, I put this in here. You have TED number 1. Go to the quarter project module at the bottom of modules. So one of the things that you probably should be working on as soon as you can, if you haven't already, is to be turning in your quarter 1 project. So you're going to submit TED number 1. You're going to click the red submit button, which you will have a red submit button. You're going to go to your Google Drive tab, and then you're going to search for the title of your Google Doc that has that, okay? And you're going to turn it in by Thursday, September 24th, if you want feedback. I highly, highly, highly recommend that you turn it in. Why? Because 1, I will be more lenient in the grading. I will be much, much more lenient as far as what I'm grading, because you haven't gotten feedback. You don't know what my expectations are. So I will give you the feedback on that TED Talk, so you can then write a better TED Talk for your other 2 assignments, okay? If you decide not to turn it in, I'm not gonna mess with late points or anything like that, but you have to turn it in by October 2nd. Now keep in mind, because of how the quarter ends, there's not a lot of grace period on this. I need it by Friday, October 2nd, so I can get it all graded and done before report cards are due on the next week. So you really need to get it all done by October 2nd. All the other TED Talks will be due on October 2nd, like I just said. Your video, you're gonna pick the best one of those three, and you're going to do a short video report on those, and that's going to be due October 7th. So you're going to do like a video, like a presentation, but you're going to do it on video, okay? And I'm going to be the only one to watch that. Where do I find the Google Doc? Mr. Franklin mentioned the Google Doc. Where is it? So it's in the tab before, so I went to previous, but if you go to modules and you scroll down to the quarter project will be the last module on here. In the quarter project template, rubric, and details. So if you click on that, here's the rubric and here's the template. So if you click the rubric, it tells you what points are worth what, okay? If you click on the template, which you should already have this, but if you haven't, you click the template and you go File, make a copy. And what I would do is I would put my name on it, Franklin Ted #1. Make a copy of it, and then I would go immediately and go File, make a copy, Ted #2, or Franklin Ted #2. And then I would do that for #3. So then I already have them made so that when you go turn it in, you just type in that title and it should pull up the document as long as you answer the questions here. Also, the points from the rubric are already in the document, so you really shouldn't have to think too much about it. Okay? So start working on it. If you haven't already, pick a good TED Talk, watch it, fill in these areas. These points is how much each of those sections is worth, okay? And over here is a description of what I'm looking for, okay? And then in the middle, you can write your answer. Pretty simple. So you can start working on that on Monday, but it's due on Thursday if you want feedback and some leniency on grading. Okay, so on Tuesday, we're gonna do a Zoom where we're going to review some stuff and talk about the next lab, okay? And so this lab is going to be Explore Learning. If you do not have an Explore Learning account, you need to email me so that I can set you up with one. I've figured out how to do that, so now I can set you up with an account if you can't log in. On this one, we're only going to do, so we already did activity A. So this time we're gonna actually just jump right into activity B and C. Are we doing C? I think we're doing C. Yeah, no, just activity B. So really simple, activity B, and we're gonna be looking at forces and acceleration. What is acceleration? Forces cause acceleration. How does that work? Okay. So you're going to answer the questions in that document. You just type your answers in the boxes. There should be boxes for every question. Okay. There we go. The next thing on Wednesday, when you're on your own, you're going to have two sets of notes. One's on acceleration graphs specifically. One's a recap input where I put all the different types of graphs together. So just real quick.
Quick recap.
Yeah. Okay, so
We have
this is actually on my YouTube channel, 97 Dragon Eyes. You can go there. I have a playlist specifically for motion graphs that I've created. So playlists, we've got distance, velocity, and acceleration graph playlists. So if you're really confused, you can go through and play it, and the playlist is set in order.
We will also,
so you can go through in order and see, you know, and kind of put things together. So some of these Mr. Bimke covered, some of these Mr. Brooks covered, but I had already made a set of videos that also explains it, so you could do that if you need to. But we're going to be watching, I think, this one and this one this week. So you'll have those video notes. Make sure you're writing a summary at the end of your video notes. Graph practice number 6 is going to be really straightforward. Read the graph, okay? Just pay attention. What's the title of the graph? Because it might ask for things like velocity, but this is a distance graph, so you have to do rise over run, those kinds of things. So make sure you're reading the title and reading carefully what it's asking to. See, this is a different graph. It's velocity versus time, so make sure you're reading the title. And then this one's acceleration. Okay, so read carefully, work through those, and on Thursday for this class, Thursday or Friday, we will review any misconceptions or questions you might have. So then our last class will probably be just working practice problems, working some example graphs, and putting things together. It will also be a review before we take our quiz on Friday. So next, you're going to have more practice looking at DVA graphs and putting the big picture together, and it's really simple questions on one hand, but because it's big picture and the main idea of what the graphing we're looking at is all about, you have to really understand what's going on from a big picture point of view. Okay, so it shouldn't be too difficult, it shouldn't take you too long, but you do have to make sure you're paying attention to which graph am I talking about, what am I actually asking for, and then you'll have your quiz. And the quiz will basically be more vocabulary practice. It will also have a bunch of graphs for you to look at for constant speed, because we can't forget the constant speed, but it will also have a bunch of acceleration stuff, okay? And then you will finish out the week with your reflection. So it's really easy on the reflection to kind of just click through and just fill in something just because, like none, none, none. So like this one, what concepts do I get and I don't need help with? You know, if you put none here, you should probably be putting something there, because this is what problems do I need help with, what problems I don't need help with. So one of these should probably be none, or I don't understand acceleration graphs, but I do get the constant speed graphs. That's very helpful to me. So the more you can put in, the more helpful to me it is, the more helpful to you it will be. Because especially once you get to college, there's going to be nobody doing this for you. It's all going to have to be up to you to go, you know what, I don't understand that. That's what I need to study. Okay? And that should wrap up the week. And then going into the weekend, you probably should be spending some of your time working on your quarter project and getting caught up. So that concludes this video. So have a good Monday. Do your best getting work done and get ready for Tuesday when we will meet. And for some of you, it might be Wednesday when we meet. So thank you and have a good day.